Okay, welcome back to problem 4. So we've done part A, which is we find the velocities of parts 1 and 2 when the spring reaches maximum compression. And that's what they are here, this 1/2 U1 plus U2, the velocity of center mass. Oh, fantastic. Okay, so now for part B, we want the kinetic energy of the system and the potential energy stored in the spring at the time shown in each of these diagrams. So to start with, the kinetic energy here is going to be pretty easy here. So it's going to be 1/2 of mv squared for each of these guys. So that's going to end up being 1/4 m times u1 squared plus u2 squared. Okay. Then for the second part, the middle part here, it's going to be, they're both moving at this speed. The entire mass, the entire system is moving at this velocity here. So that's going to be 1/2 m times u1 plus u2 squared, right? So now the question is, no, I'm sorry, excuse me. This is going to be actually, yeah, right, so I did that wrong, sorry. Come on, back up. Okay, so it's going to be 1/2 m times 1/2 u1 plus u2, all of it squared. So that's going to be actually 1/4 u1 plus u2 squared. Okay, so now I want to expand this all out a little bit and say that the well, we want to find the potential energy stored in the spring, right? Which is going to be the difference of these two, of this kinetic energy and this kinetic energy. So I want to expand these out a little and say this kinetic energy is m times 1/4 u1 squared plus 1/4 u2 squared, okay? And this kinetic energy is going to be equal to, let's see, it's going to be m times 1/8 u1 squared plus 1/4 u1 u2 plus 1/8 u2 squared, okay? So starting from here, or actually starting from here and going to here, for this step here, delta K is going to be the final kinetic energy minus the initial kinetic energy. And when you do the math there, it's going to be equal to m times negative 1/8 u1 squared plus 1/4 u1 u2 minus 1/8 u2 squared. Okay. This problem is less pretty than I thought. So, let's see, factor stuff out. So what this means is that, let's see, for the first one, obviously potential energy for the spring, whoops, that's exactly what I said I didn't want to do. No, stop, all right. There we go. Potential energy for the spring here is obviously 0. And then what's going to happen is this represents a loss in kinetic energy between 1 and 2, which is going to be a gain in spring potential energy. So I guess we could say in this stage, US is going to be, and it's going to work out, let's see, it's going to work out to be 1/2 m times, yeah, I don't like this. Okay, so times u1 minus u2 all over 2 squared. So this line in here, okay, and pardon that little parenthesis, jutting in, that's the spring potential energy. Where I was trying to go with this, I think, tell you what, let me just sort of leave that there. And I'll tell you where I was trying to go with this conceptually, so at least you could sort of learn what I meant for you to learn. Okay, so that'll be the